All right. So, hello and welcome everyone. So, we are live right now. I hope I'm audible to all of you. All right. Please let me know the live chat is am I audible? Am I audible to all of you? Okay. Great. So, welcome back to this amazing platform of Tutee learning. So, today we will start our discussion on the very basic topic that is going to be the another most important topics of three-dimensional geometry, that is going to be planes, right? So today we will discuss about planes in detail, and we will see that how we can derive the basic equation of a plane, and also we will also try to understand that how we can solve the important questions. Okay, so all those part we will try to discuss in this today's lecture. So let us start. So as of the last class, you already got an idea that when we were proving for the results for two straight lines to be coplanar, right? So two straight lines to be coplanar, that basically means that two straight lines lies on a plane. So let us now discuss about what do we actually mean by plane, right? So if we talk about plane, so planes, you can understand planes as a simple page of a paper. Okay, so let us say that plane is something like this. Okay, so you can see a piece of paper, right? So you can assume the plane as a piece of paper which is straight hold like this, right? So this is can be assumed to be a plane, right? Now let us try to understand what are the important parameters required for plane. Hi Vivek, welcome back. Okay, so you can assume this sort of thing as a plane, right? So how do I need to define plane? That will be very important and crucial in order to understand that how we go about writing the equation of the plane. So let's try to get over this. So let us say that my plane is something like a piece of page, or just one page. Now a plane, so in this particular plane, if I have, let us say I have point P which is given as x comma y comma z, right? So let us say in this particular plane, the point P x comma y comma z moves in a certain rule that they lie in the 3D region on the surface or on a line. That is simply a point. So if I keep on varying this particular point P across all the points on the plane, then we will be in a 3D region which is on a surface or on a line or simply a point. Whatever we get as a region of P after applying this particular rule is called as a locus of plane, right? So when we need to define any geometry, we generally define geometry in terms of something called as locus, which follows some geometric condition. Similarly, over here, the geometric condition is very simple, that this particular point P lies on the same surface, or maybe lying on a straight line, or maybe lying as just a point. Then this is called as a plane, right? Now let us discuss about the plane or curved surface, right? Now what is the basic differentiation between a curved surface and a plane? So when I talk about surface in general, surfaces can be assumed to be any general curvature, right? So I can have a shape like this, right? Something like this. So this is kind of a curved surface. However, in very important understanding about plane is that the plane will have zero curvature at all points on the surface, right? So that is very important to understand, that a plane is just like a piece of page, right? So if I understand this particular definition, that let us now discuss, or if I talk in terms that, let us say I take a point Q to be any other point and its locus such that all the points on the lies on the straight lines. Okay, so let us take, I take up n number of random points P, Q, R and so on, right? And all of those lines are lying on the same straight line. Then whatever locus I will obtain by this variation of this point P across that is something defined as plane, right? Whereas in case of curved surface, I cannot do that. So if I take one straight line and I want to vary the point P along the, and I try to obtain the locus, I won't get a curved surface. So curved surface is different from a plane in this particular basic difference. Okay. So in other words, the straight line that I have PQ, however small it is or whatever direction it may lies, completely lies on the focus, okay, or the locus, okay. And it is very important to understand this basic differentiation between a plane and a curved surface. Is this part clear to all of you? Is this part clear? So this is how we need to understand about planes. Now let us try to understand that how do we define the general equation of such planes. So if I go about to discuss the general equation of the planes, okay, so if I go about to write the general equation of any plane, how am I going to write that? Let's try to understand this in a detailed manner. So what I said that a plane is a locus of all points lying on the same surface or lying on the same straight line or lying as a simple point, right? So that is a basic understanding. Now why do I call a same surface, and or maybe we can assume a surface to be a combination of multiple lines, like infinite lines, right, having the same or the parallel lines, okay, and having lying on the same plane. Okay, so that is how I am defining plane. Okay, so you can consider that if I have a straight line and all the points on lies on the same straight line and I vary it accordingly, so then this particular part or whatever I 3D surface I obtained is just a plane, right? So let us try to understand that how can I define this particular plane thing, right? So if I am to define the plane, there are two important things that we need to understand in order to define the equation of a plane. So let's try to see that what is the basic understanding or what are the basic requirements for defining any general equation of plane. So let us say I have this plane with me, and definitely I will know that any point that is lying on the plane. So let us say I know the point P, which is given as alpha comma beta comma gamma. This particular point lies on the plane. So this particular point lies on the plane. Okay, so we have a particular point which lies on the plane. This is given to us, right? Now, if I need to define the general equation of plane, I need to take up any general point on this plane. So let us say I take up a general point on this plane, and also I denote the position vector of this point R as small r vector. Similar manner, I denote the position vector of point P as small p vector. So therefore, I can obtain point P as alpha I cap plus beta j cap plus gamma k cap. So this is just a position vector, okay, which I'm writing as short form as P dot V, right? So now this R point is my arbitrary point which is having the coordinate x comma y comma z. So this is a variable point, right, which is varied across the surface or the plane to get the equation of the plane, right? Now if what I understand is that plane, so if I consider these 2 points on a plane, by considering 2 points on a plane, I cannot generally find out the equation of a plane. Now, if you recall that in straight line, what was happening is that even if I know 2 points that is lying on the same straight line, I can be in a position to write the equation of a straight line. However, in case of plane, I am not actually in a position to write the equation of the plane itself by just having 2 points, right? However, the locus was defined in such a way that if I vary the points such that they lie on the same straight line, then I will get the plane thing, right? But one more thing is missing to this particular plane. Now, to understand this particular part, let me take the same example. Let me take this particular page as a plane. Now, to understand that what is another very important parameter that is relating to a plane is that if I consider a normal to the plane, let us say I consider this pen as a normal vector to the plane. Now, if I vary the orientation of this plane, this normal vector is also changing its orientation. So what I understand is that by defining another vector which is perpendicular to the plane, I am going to define the uniqueness or the orientation of the plane, right? So please try to understand this again. So what I'm defining by this pen denotes a vector which is perpendicular to the plane, perpendicular to this all points on this plane. Okay, so any point on the plane I take it, and this particular vector, this black pen, is going to be perpendicular to all the points in the plane. Now if I say that if I just change the orientation of the plane to obtain different planes, then the orientation of this black vector or this pen vector will differ. So this way I can define a uniqueness or a unique parameter that is associated with a plane. So if I'm going to define, the unique parameter of a plane, Vivek, this is a live lecture, okay? So if I'm going to define this as the uh, unique property of a plane, then I will have to define another very important property that is called as the normal of vector to the plane, which is normal to all the points in the plane. So this is my normal vector, which is normal to any point in this plane, right? Is this part clear? Is this definition clear? Okay, so why do we need to define this? I hope this part is clear, right? Okay, any questions? So now we have formulated the background of this question by defining any variable point. We already have a known point and we have defined a perpendicular vector or a normal vector to all the points of the plane, right? Which is given as follows. Now if I have this form, then the equation of plane is a very simple thing. We can define the equation plane by forming this as one vector and normal vector is already given. So I can use the concept of dot product for perpendicular vectors. So one of my vector will be PR vector. So if I dot product with this n vector, I would get the result as 0 vector or 0, right? It is a scalar product. It's a 0 because these are perpendicular. This PR vector is perpendicular to this normal vector, right? So this result is always going to be 0. So by this form, I can define my r vector minus p vector times n vector to be 0, right? Now my unknown is r vector. P vector is my known vector. So from here, I can obtain this relation, that is r dot n vector is going to be equals to p dot n vector. Now this p dot n vector is a known result and this is a scalar result which I can give by some constant, let us say d. So d denotes any constant. This particular product will be constant for a specific plane. So for any specific plane, this scalar product is going to be constant. So in this manner, I can denote the equation of the plane as follows. That is r vector dot n vector is going to be d. All right. Is this part clear? Is this part clear to all of you? So this is how I can define the equation of the plane in the vector form. Okay. So this is the vector form of the equation of a plane. This is a vector form of the equation of the plane. So this is how I obtained the equation of the plane in the vector form. Now from this vector form, converting back into the Cartesian form would be just a simple step. Okay, so that can be very easily performed by replacing this r vector with this x, y, z. So if I do that, and let us say the direction ratio of this n vector is given as a comma b comma c. In this manner, I can write the equation of this plane as ax plus by plus cz is equals to some constant d. Is equals to some constant d. Is this part clear to all of you? So this is the Cartesian form of writing the equation of a plane, right? So that linear equation, the whatever you solved in your chapter of determinants, that linear equation that you solved for is nothing but you solved actually for the equation of plane. Okay, so in chapter of determinants and matrices, if you have studied so far, then you must have seen that there is a part where you have to solve system of linear equation in 3 variables, right? So any system of linear equation in 3 variable actually denotes the equation of a plane. So this is the equation of a plane, right? Where the formulation is as follows, that this is my plane. The direction ratio of this normal vector is simply the coefficient of x, y, and z. Is simply the coefficients of x, y, z. They denote the direction ratio, okay, which denotes the direction ratio of this normal vector, okay. So and x, y, z is any random point which can be varied to get the equation of the plane, right? So x comma y comma z is any random point on the plane, and this d is obtained, and this point d and whatever d you are seeing over here is just simply obtained as by the known point. So let us say x1 y1 z1 is my known point, then the d can be obtained as x1a plus y1b plus z1c. So this is how I obtain my constant value d. Okay, is this part clear? Is this formulation clear to all of you? Please let me know in the live chat so that I can understand whether you are able to understand this particular topic or not. Okay, please understand these two basic form of equation of plane. If you understand these two basic form of plane equation, uh, you can be in a position to write any general form of a equation of plane. Okay, so whatever modification in question can be asked up, you can definitely come with the answer to that. Okay, so there can be multiple variation of equation of planes which you can already try to answer once you understand these basic definitions. Okay, is this part clear to all of you? Is this part clear? Is this part clear to all of you? Please let me know in the live chat. Is this part clear? If you still have any questions, please let me know, okay, so that I can help you out. Great, Aman Verma. Great. Okay, so let's now jump on to discuss about other modification that can be done to this equation of plane. Okay, so let us try to extrapolate this particular results of this equation of planes to understand another form that is also called as the normal form, right? Now normal form of plane is very simple. So if we have the normal vector like this is my equation of general equation of plane, right? Now in normal form, this is also called a normal form. However, sometimes you might also have the result as the r vector dot n cap, right? R vector dot n cap, and this result is given as d by mod of n, right? So this is another modification of the results. Okay, so please don't get afraid whenever you see these kinds of result for the equation of plane. Okay, so this is also the equation of plane in the normal form. However, another interesting equation of plane is that now you must have already studied this concept of parallelogram law of vector addition, right? So if I consider, let us say I take up two lines which denotes the corresponding edges of my parallelogram. Let us say point point P is given with an is a known point which is given with a position vector A, and this particular point let us say it is B, this line is L, and this line is M, or let us say this point as M and N, like this way. And then if I consider this parallelogram, so the summation of these two vectors will be the sum will be also lying in the same plane, right? We've already seen this particular result, that is any linear combination of a vector plus b vector. If a vector and b vector are there, then it will definitely lie in the same plane or they are coplanar, right? So using that particular result, so if P is this particular point and L is this way, right? And M is over here, right? And M is over here, and let us say this particular vector denotes the C vector and this particular vector denoted by B vector, right? So in this way I can write the PL vector as some lambda times of B vector and PM vector as mu times of C vector, right? Mu times of C vector. So with this formulation I can write this particular vector, let us call it as Q. So PQ vector can be written as A vector plus lambda times of B vector plus some mu times of C vector. So this combination of vector, and if I'm calling it as a general vector R, then this is can also be given as the equation of a plane passing through a given point and parallel to two given vectors. Okay, so if I have to write the equation of a plane, let us say this is my equation of the plane, which is passing through a given point, which is P, whose position vector is A, and is parallel to two given vectors. So if I have two vectors like this, and it is parallel to these two given vectors, so my result for the R vector or the vector result of the equation of plane can be simply given like this. However, this result can also be obtained. So if I say that I know that my B vector and C vector are parallel vectors, okay. Sorry, A vector and B vector can be any vector, okay. However, the plane is parallel to these two vectors, then this n vector or the perpendicular vector can be simply by doing a cross product, right? All right. All right. So I hope this is clear to all of you. Okay. So I hope this part is clear to all of you, right? So this is how we can do some multiple modification to find out or formulate the equation of plane. Okay. So I hope this particular discussion is clear. Now let us try to understand about another formulation of plane equation, right? So if you recall, in your straight lines there is something called as an intercept form, right? Similar to over here, there is also an intercept form of the plane, right? So let us say I have my plane something like this, which is intersecting the x-axis as a comma 0 comma 0, y-axis at b comma 0 comma 0, and z-axis as 0 comma 0 comma c, right? Okay, so if I have this as my plane, now there is an intercept form of this plane is that the equation of the plane can be written as x by a plus y by b plus z by c is equals to 1. Okay, so with this part of formulation, I can generally write the equation of the any plane, right? I can write the equation of any plane, and this is also called as the intercept form. So if I know the intercept, so if I know the intercepts, so if I know the intercepts of the plane, if I know the intercepts of the plane, then I can use this particular formulation to formulate for the equation of the plane in the intercept form. All right, is this part clear? Is this part clear to all of you? So this is called as the intercept form of a equation of plane, right? Okay. Now, once we understand this particular results, that in order to formulate the general equation of any straight line or plane, we need two parameters. That is one point which is lying on the plane and one normal vector to the plane, right? So if I know these two quantities, I can easily write any general equation of any form of plane, right? Okay, so let us try to solve some problems to understand that how do we go about formulating some of the problems, right? So let us take some simple examples. So, so if I take some simple example, let us say, so there is a question which says that, now this is going to be an interesting problem, okay? So I would like all of you to first of all give a try, okay? So whatever we have understood so far, based on that particular definition, on how to write the equation of plane and the formulation, please try to first of all formulate this problem, okay? So the ratio in which this particular plane where I have my equation of the plane. So let us first of all try to draw or have a pictorial understanding of the plane. In questions of mathematics, trying to draw or whatever the formulation of the problem is going to be helpful, especially when you are dealing with some questions which has a lot of multiple steps of calculations, right? So you have to plan before how to proceed with the question. So in this kind of questions, drawing the question or doing a pictorial representation helps you actually. Okay, so this is my plane whose equation is given as x minus 2y plus 3z is equals to 17. X minus 2y plus 3z is equals to 17, right? So this is my equation of the plane, right? So this is the equation of this particular plane. Okay, so this is the equation of the plane. Now it is said that you have to find out a point on the plane, and you have to find out that in which ratio any point that this part. So if I have these 2 points which is given as minus 2 comma 4 comma 7, and my point B, let us say it is given as, so over here it is given as 3 comma minus 5 comma 8, right? So you have to find out that in which ratio this particular line is being divided by the plane. So you have to find out this particular ratio. So let us assume the line AB be divided by the plane in the ratio of, okay, let us first of all assume in the ratio of lambda is to 1. So let us assume the ratio as lambda is to 1, right? And you have already seen that from your junior classes that whenever you have a questions of section formula, instead of assuming the section formula, the ratio as m and n, it is always essential or always helpful to solve the problem as lambda is to 1, right? Because in that case, you will only have one variable, right? So that's why let us first of all assume the ratio to be lambda is to 1, right? So once you formulate this problem like this, the only thing over here to solve is that you have to get an intersection point of the plane and the line. So in order to do that, what I'm going to do over here is that I will first of all find out the equation of this line. So the equation of this line AB can be given as, let us say, x minus of minus 2, and then the vector would be given as 5 is equals to y minus 4 divided by 9, minus 9, and then z minus 7 divided by 1. So this is the equation of the straight line AB, right? And let us assume this as some mu. So if I need to get this particular point, let us say this particular point which lies on the plane is P. So this particular point can be given in terms of parameter mu as minus 2 plus 5 mu, 4 minus 9 mu, and 7 plus mu, right? All right, so this is my point P. Now once I obtain this particular point P in terms of mu, I can simply substitute over in this equation of plane to find out that what is my point P. And once I find out my point P, then I can use a simple formula of the section formula to find out the final ratio. So if I do that, if I carry out few lines of algebra, so the algebra is as follows. Okay, so if I carry out this calculations, so you can also do this calculation by yourself. Okay, anyways, so 5 mu and this will be 18 mu. So 5 plus 18 would be 23 mu plus 3 mu would give you 26 mu, right? So you will have 26 mu, and then if you add the constant part, it's minus 2 minus 8 minus of 10 and then plus 21, which is going to be plus of 11 is equal to 17. So this you can solve for mu, which will be equals to 6 upon 26 or 3 upon 13. So you will get the value of mu as 3 upon 13, right? Please check the calculation. I might go or do a mistake over here, but please check the calculation again. Okay. So once you obtain the value of this point mu, or then you already have your point P. So you already have your point P, right? You already have the coordinates of your point P. Now once you have the coordinate of point P, and this point P can also be given by the section formula ratio, that is, we're assuming it as lambda is to 1. So if I use this particular result, then 3 lambda minus 2 by lambda plus 1 would be the x coordinate of point P. Similarly, minus 5 lambda plus 4 divided by lambda plus 1 would be the y coordinate of point P, and 8 lambda plus 7 divided by lambda plus 1 would be the z coordinate of point P. So you have already obtained your point P, so you can substitute back in these results to obtain this value of lambda. So if you carry out the following lines of algebra finally, so which I have already done, so you can check it out. Okay, I have solved it previously. So the value of lambda which I obtained was 3 by 10. Okay, the value of lambda which I obtained is 3 by 10. Therefore the ratio would be simply equal to 3 is to 10, right? Because ratio we have to not give like 3 by 10 is to 1. It's not like that, right? So it has to be established as 3 is to 10, right? So with this, the final answer to this question is going to be option C. Now please note that this is a question that was asked previously in the JEE Mains paper. Okay, so I took this question from the JEE Mains paper, right? So these kinds of simple problems are generally being asked up in the paper. Okay, so only thing that you need to know or understand is that if you know that what is the basic way to formulate the problem, any general problem, then you can formulate and solve for any types of problems that can be asked in a paper. Okay, so please mind this particular part up. So whatever problems you're understanding, please understand those problems right from the very basic thing. Okay, so once you understand the basic part, you are in a position to solve for any types of questions. So please make sure that whenever you are learning anything, please try to learn it from the basic part. All right. And also, don't just learn it for the sake of learning. Okay. Just learn it as a new experience and try to establish and try to appreciate that beauty of this particular problems, right? And why or how does mathematics is just a poetry of the nature, right? So it is a very well known by statement by some philosophers, right? So they generally call as mathematics as just a poetry, okay, a poetry of the nature, right? Nature is the reality, right? However, mathematics is not the reality, it is more closer towards the reality, right? So whatever is happening in the reality, if we are trying to formulate that particular thing by using some mathematical concepts, then we will be trying to understand the nature or the reality in a more better way, right? So that is what mathematics is trying to do. So whenever you are learning something, please try to establish and appreciate the fact behind every formulations. Okay, so there are some assumptions, there are some formulations, you have to I understand the formulation, and then you have to appreciate this particular beauty, and that's how you can proceed for any general solution of problems. Okay, so whatever exam comes up, you can easily solve the problem. Okay, don't just study for the purpose of clearing an exam, study for the purpose of learning it, purpose of understanding the nature. That's all I would like to say. And with this, thank you for watching this session, and thank you for your patience on this particular lecture. And we will be discussing about the further topics about how we can solve for the intersection of a point on a plane, line on a plane. Okay, and the concept of this mirror image, like considering the plane as a mirror, how we can solve those kinds of problems, and we are going to discuss about that in our upcoming lectures. So if you're into this particular platform, I would request you to please subscribe, share these videos, and also like these videos. Okay, because if you like these videos, I will try to understand whether you're able to understand these videos and whether you're able to understand these lectures, and should I continue with better content or not, right? So that will give me a motivation to prove and give a better content on this particular platform, right? Already there are a lot of content on this platform, right? So if you haven't subscribed to channel, please subscribe and hit the bell icon, so that whenever we are live every day, you get a notification and you can attend the live classes and you can ask your doubt live on this particular platform. So with this, thank you for all your lovely attention, and I hope to see you soon in our next class. So till then, bye bye.